Hi, I'm going to be doing an experiment on light out of this book, The How and Why Wonder Book of Light and Color, and I'll show you the experiment we're going to do. It's going to be light project number 4. It's reflection, and we're going to measure the angle of reflection and try to see if it's equal to the angle of incidence. Okay, and we're going to follow this setup, and I'll show you on the camera. I'll just do this. First, I'll show you the setup. I just have this mirror. It's just a bathroom mirror. It's in a frame. So in order to actually use it, I've stacked some books up in front and behind it so I can actually push up against the edge of it to make a little table. Okay, so I didn't want to have to take it out of the frame, but I essentially get the same result by doing this. Okay, first we're going to create a line. It's going to be a line that will represent a ray of light, let's say, coming in. Okay, and for this purpose, I can just draw a line at any angle I want. Okay, so I'm not going to do anything special, and I'm just going to pick an angle here, and I'm just going to draw. The idea is just that it's a straight line. Okay, that will then be pushed up against the mirror. That is going to represent an incident ray of light, and it's going to allow me now to place the ruler, and this is just the way it's being done in the book, although you might want to, set it up, depending if you're right-handed or left-handed, and you want to set it up so you can eyeball. See, you're using your eye to line up the ruler to be coincident with the image, okay? And your eye, can do a pretty good job. But it does take a little bit of practice. You might do this a couple times, okay? And I don't like to step on the pitch. I like to set the ruler back so I think I can line it up better that way, okay? And, you might want to have the right pair of glasses on. So anyway, that looks lined up to me. So I'm going to make that line. Now, once I have the line, I can extend it, okay, which I can't do with the ruler, right, while it's like that. I could extend the line now up into the point, okay? Naturally, there's going to be some errors here, okay, that's okay. Now you notice they don't actually come to a point. They come close to a point. The reason is because the mirror has a glass front, which is about 1/16 of an inch. The reflection is actually taking place slightly behind that, okay? This method of doing it, which is the method in the book, takes care of that, okay? That error will not affect it if you line this up. Now I'm just going to turn this over to make it convenient for measuring the angle, and I'll measure the angle on each of these points. In this case, you want to have some practice with the protractor. So what I'm getting on this particular side, and I'm just going to do it, it's 52. I would do it to a half. I would try to estimate it if it was in between, but this one is 52. I could say 52.1 maybe, okay? Now I'm going to adjust the protractor. Now here, when I do this, I have to swoosh it over a teeny bit to account for that, okay? And now, on this angle here, it's spot on 52. I'm going to put 52.0, okay? And now, I've measured the angles, not from the normal, which is the normal way of doing it. I've measured it from the plane, and it's only because it's easier to measure it that way. See, I don't need to draw a perpendicular and then measure them, because if there was any error in drawing the perpendicular, that would get reflected, okay? So on this particular measurement, this was 52. This one was, because this was the way it was set up, this was actually the incident angle. Call it theta incident. And this one over here was 52.1, and that was the reflected angle. Now, the actual, if you wanted to express this in terms of, and I can call these, phi, because theta is usually reserved for the angle measured from the normal. So this would be 38.0, because they have to add to 90, okay? Even though I didn't measure it from that way, it's equivalent, okay? And it's probably slightly more accurate. Okay, and this one, 37.9. Okay, so this came out to within, within a tenth of a degree. Okay, so that's pretty good. Just so you see the numbers there. Okay, and it is actually just according to the procedure. I originally did this a slightly different way, and in the other way that I did it, it was the thickness of the glass actually produced an error in that case, just according to the specific way I was using my protractor and such, and I ended up with a 2 or 3 degree difference on these two. Okay, and that's the reason I put this together. And while I was putting it together, I realized if I actually followed the procedure as written, it would take into account, because these two do not actually meet at that line. The book doesn't mention anything about that, but that's the way it's going to come out because of the thickness of the glass. Okay, thanks. Bye.